Alrighty, two topics for today in this last video for this chapter. The first topic is concentration. And concentration has to do with the quantity of a dissolved substance in a certain volume of solution. And what I'm going to use to explain this to you is the concept of having chlorine in water. Now, at room temperature, chlorine is quite honestly a poisonous gas. But you can dissolve chlorine in water, and we're familiar with this in our everyday lives. If you happen to live in a place where your drinking water has been treated, it is very common for water treatment facilities to put chlorine in drinking water to kill the bacteria. Now, as long as they don't put a whole lot in, you may not even notice the fact that there's any chlorine in your drinking water. However, if you go to a local swimming pool, the chlorine in the swimming pool is put in swimming pools for the same reason, but they use a much greater quantity of chlorine, and you'll notice that if you happen to accidentally take a drink of pool water, it doesn't taste very good. It's still chlorine and it's still water, but there's enough more chlorine in there that you can really taste it, and it kind of makes your stomach hurt if you drink too much pool water, so I wouldn't recommend that. Bleach, which your mom may or may not use when she does laundry, is also chlorine in water, but it's far more concentrated than the swimming pool and certainly far more concentrated than your drinking water. In fact, if I unscrew the cap off a container of bleach and I'm not really careful, I can have an asthma attack just from inhaling that bleach. And so bleach is something that people with asthma have to be really, really careful around. In fact, other people should be careful around it too, because the fumes can be so dangerous. Now, in all three of those cases that I just mentioned, your drinking water, your swimming pool water, and your bleach, all of it is chlorine gas dissolved in water. So it's the same two components, but the difference in those three is how much chlorine is dissolved in that water. And so concentration makes all the difference in how powerful your cleaning solutions are, in how dangerous pollutants are, in how dangerous toxins are. And so concentration makes a huge amount of difference in all of those things, okay? So I gave you some other examples in your homework to help you kind of think through the issue of concentration in some other areas. So hopefully that will help. Finally, the other topic we're going to hit today is called saturation. At a specific temperature, a solution can only hold so much of a solvent. An example of this is, again, if you have iced tea and you're trying to sweeten it by putting sugar in it. You may have noticed that you can only put so much sugar in it and get it to dissolve before all of the sugar just starts collecting at the bottom and sitting there. And it doesn't matter how much you stir it and how patient you are and how long you wait, at some point that iced tea cannot dissolve any more sugar. It just sits on the bottom. And then your mom yells at you because you put all that sugar in there and you're not even going to drink it because it's just sitting on the bottom. So at a certain temperature, it can only hold so much solute. It can only hold so much dissolved sugar. And I think I had mentioned that if you like hot tea, what you can actually find out is if you take that iced tea and you put it in the microwave and you warm it up, all that sugar will dissolve, and you can even dump more sugar in it if you want to. So at a higher temperature, most of the time, no, not always, but most of the time, if you raise the temperature, you can dissolve more stuff in your solution. So the solubility is how much you can dissolve. Solubility is how much you can dissolve at a specific temperature. So if you raise the temperature, most of the time you can raise how much you can dissolve. Now, there are three terms where we can actually describe the extent of saturation of a particular solution. So if you've got completely unsweetened iced tea and you dump a packet of sugar in it, at that point your solution is unsaturated, because if it's got no sugar or just a very little bit of sugar in it, you can certainly get more dissolved into it. Now, when you get to the point where the iced tea will not take any more sugar, you cannot get any more dissolved no matter what you do, at that temperature, then your solution is saturated. It is holding as much sugar as that glass of iced tea can hold, unless you decide you're going to go stick your iced tea in the microwave. So at that temperature, it's holding as much as it can hold, and you'll be able to tell that that's true because you're going to start having sugar sitting on the bottom. When the sugar sits on the bottom, you know that no more will dissolve and your solution is saturated. So supersaturation means that it's actually holding more than it normally can hold. How can that even be a thing? A lot of elementary students in their elementary science classes have grown crystals at some point. And if you've been fortunate enough to be able to do that, when you grew crystals, you made a supersaturated solution. If you've never grown crystals before, I would recommend that you search the internet and see if you can figure out how to do that, because it really is kind of a very neat process to grow crystals. Normally what you're going to do, just to give you a summary, is you take what's called alum, which is a white powder, and you dissolve as much of it in a certain amount of water as you can possibly dissolve. You stir it and you stir it and you stir it and you get it, get as much dissolved as you can, and then you put extra alum in there. And then once you do that, then you warm the solution up. And once you warm it up, it will then be able to dissolve more of the alum, okay? You don't have a supersaturated solution yet because you've raised the temperature. But when you dissolve the extra alum in there, which is more than it would hold at room temperature, and then you take that solution, you set it on the counter, and you don't disturb it, you don't touch it. And some solutions, you will be able to cool it down very, very slowly, very gently, very carefully. And if you do that, sometimes that extra stuff will stay dissolved in there, and that's when you have a supersaturated solution. And so that supersaturated solution then is what allows you to suspend just a little piece of alum on your string, and then what's got all that extra in there will then start collecting on what you suspended on the string, and you'll be able to grow that crystal. So growing crystals requires supersaturated solutions. Normally in a situation like that, if you have something where you have a saturated solution, you add more, you warm it up, and then if you cool, especially if you cool it down quickly, most of the time the extra stuff will just fall right back out of solution. You'll find it sitting on the bottom again. So if you're trying to achieve a supersaturated solution, it definitely requires a lot of very slow and careful cooling in order to achieve that. So that's concentration and saturation, and we're about to the end of this chapter.